Yeah, good evening, friends, and welcome to interview preparation session. So today, let's start with some questions on statistics. Okay. Okay. So let's start with what is central limit theorem. So, friends, what is central limit theorem? Okay, central limit theorem states the distribution of a sample. So we take a sample from a population. So the distribution of that sample, which is comprising of a large sample size, means greater than 30. It is always normally distributed. It says that it is always normally distributed. Okay. So in other words, we can say the original population distribution has no effect on this population distribution of the sample. Okay. Next, coming to the next question. What condition should be met for central limit theorem to be true or to hold, you can say. So what are the different conditions that should be satisfied for central limit theorem to be true? Okay, there are mainly three conditions that must be satisfied. First is we should have a random sample. Okay, random sample must be there. Second is values uh, should be independent, you can say. So values should be independent of each other. Okay. And third is sample size should be large. Sample should be large. Generally, we take it as greater than 30. Now coming to the next one. Next one is what is an outlier? What is an outlier? So we can say outliers are those points or those data points within the data set which have which varies largely in comparison to other observations. So other data points, it has either very high value or very low value in comparison to other observations. Okay, so and this outlier can also be said that it is a noise in the data. So it decreases the accuracy as well as efficiency of the model. Okay, so that therefore it is crucial that we should either remove them or do some corrections for them. Okay, now next question is how to screen the data set for outliers. How to screen the data set for outliers. Okay, so for this, there are two methods. First is using IQR or using standard deviation, or we can say Z-score. Okay, so using IQR or using Z-score. Okay, IQR, we know box plot. So whichever is beyond the IQR, we take it as an outlier. For this Z-score, what we do is Z-score, we can obtain by normal distribution by calculating the size of one standard deviation and multiplying it by 3. So we take one standard deviation, multiply it by 3. So if it is an outlier, no, so the Z-score will be above or below 3. Okay. So if the Z-score is above or below 3, it is an outlier. If the Z-score is negative, the data point is said to be below average. And if it is close to 0, it is close to average or close to mean, you can say. Okay, next. What is an inlier? So there is something called inlier also. So what is an inlier? Okay, so like outlier, inlier is also an error point, but it lies within the IQR. So within the range it lies, but still it is an outlier. I mean, it is an error. And if we remove it, our accuracy increases, model accuracy increases. But unlike outliers, it is very hard to detect. And it often requires external data for accurate identification. So it is very hard to find. And to find this, we require external data for its identification. Okay, next. What are the properties of normal distribution? So what are the properties of normal distribution? So it is also known as Gaussian distribution. And if we see this, it is like a bell curve. So something like this, if we are having, so it is something like this. Okay. So we can say uh, it is first is it is symmetrical. Symmetrical about mean. It is symmetrical about mean. It is unimodal. Means it only has one mode. Okay. And most of the data lies at the center or mean. Also, the data is sparse at the ends, you can say. And also it has central tendency. Which is mean equals to median equals to mode. Okay. And they are perfectly symmetrical about the midpoint. Now, next question. What is hypothesis testing? So what is hypothesis testing? So we do hypothesis testing in statistics to see if a certain experiment yields some meaningful results or not. Okay, so we see the statistical significance of an insight by determining the odds of the results occurring by chance. Okay, so first thing to know here is null hypothesis. So first we declare what is the null hypothesis. Okay, then we calculate the p-value from it. After calculating the p-value, we calculate alpha value, or we can say significance value. Okay, and if the null hypothesis is true and it is less than alpha value, if okay, sorry, if the p-value is less than alpha value, no, the null hypothesis is rejected. But if it is greater than alpha, this null hypothesis is accepted. And the rejection of null hypothesis indicates the results obtained are significant. Okay. So for this, we calculate first p-value. We calculate the p-value, then alpha value. Then we compare it. So if p-value is greater, p is greater than alpha, then null hypothesis accepted. If p is less than it is rejected. And when it is rejected, we can say results are statistically significant. Next, what is p-value? Now, what is p-value? So we can say, yeah, we can say p-value in statistics is a number that indicates the likelihood of data occurring by random chance. Okay, so p-value is the number which indicates likelihood of data occurring by a random chance. So for example, if we are having p-value of 0.5 and it is less than alpha value, we can conclude that there is a probability of 5% that the experiment results occurred by chance, or we can say 5% of the time the results were by chance. Okay. Now, next, what are the errors? Errors in hypothesis testing. What are the errors in hypothesis testing? So we are having two errors. Type 1, type 2. So what is type 1 error and what is type 2 error? So type 1 error is null hypothesis is rejected when it is true, even when it is true. Okay, it is also known as false positive. Okay, now type 2 error is when null hypothesis is rejected. No, null hypothesis is accepted when it is false. Null hypothesis accepted when it is false. It is also known as, sorry, it is also known as false negative. Okay, next, when to use a z-test and a t-test. So when to use a z-test and when to use a t-test. Okay, now a z-test is used for hypothesis testing in statistics with a normal distribution when the sample is very large. Okay, it is used to determine the population variance in case the sample is very large. And t-test is used with a t-distribution, and it is used to determine the population variance when we have a very small sample size. Okay, so it depends on the sample size. So if sample size is large, or we can say greater than 30, we use z-test. And when it is less than 30, okay, let me just write it down. So when n is greater than 30, we are using z-test. N is less than 30. Oh, sorry, this is small n, sample size. We use t-test. Okay. Okay, now coming to data science. So taking the first question from data science. So first, what is data science? So what is data science? So we can say data science is an interdisciplinary field which uses scientific methods, processes, algorithms, systems to extract knowledge and insights from structured, unstructured, noisy data and apply that knowledge to get actionable insights from the data across a broad range of application domains. Okay. So if I can write it in points, interdisciplinary field. It takes structured data, structured, unstructured, noisy data. Okay. And we get from this some patterns. Okay. You can say patterns or knowledge which you use to derive insights. And these insights we use for a broad range of application domains. Insights used in broad range of application domains. Now, next, what is machine learning? So we can say machine learning is that a field of study which gives computer enough capability to learn without being explicitly programmed. Okay, so with very less programming, it gives the computer the ability to learn. So we can say machine learning is also a subset of artificial intelligence. Okay, it allows machines to learn from their experiences without any coding or with minimal coding, you can say. Now next, what is deep learning? What is deep learning? Now deep learning, we can say it is a kind of machine learning in which neural networks are used to imitate structure of human brain. Okay, just like how human brains learn from their information, here machines are also used to learn from the information provided to them. Okay, so here we here we are using neural networks, okay, to imitate how the human brain functioning to gain information. Okay, coming to the next. So what are the different learning methods in machine learning? What are the different learning methods in ML? So basically there are three learning methods that we know of in machine learning. So first is supervised, next is unsupervised, third is reinforcement learning. Okay. Now next, what is this supervised learning? What is supervised learning? So what is supervised learning? So supervised learning is that kind of learning in which we are having labeled data, or we can say the data is, we know the output of the data and we have the input of the data. We just find out the patterns which relates the input and output data. Okay. Next, what are the types of supervised learning? So what are the types of supervised learning? So basically two types: classification and regression. Okay. Now, what is classification? So what is classification? So we know supervised learning are those in which the output is known, input is also known. Okay. So when the output is in discrete form or in the form of classes, we call it as a classification problem. Okay. Output, you can say output is discrete So we can call it as a classification problem. Similarly, for regression, we are having output is continuous. Okay. So supervised learning method in which our output is in continuous form, we call it as regression, and in which output is in discrete form or in the form of classes, you can say, it is known as classification. Now, what are the examples of classification and regression? So here we can give examples as logistic regression, okay, we are having logistic regression, KNN, naive-bayes, decision tree, random forest. So basically, decision tree, random forest are both. They can be used for regression also. Okay, and in case of this, we are having uh, linear regression. You can say. Linear regression. Others also like random forest, decision tree, those are common. Okay, next, coming to unsupervised. So what is unsupervised learning? Now, what is unsupervised learning? So the thing is, in supervised learning, we required supervision to get the, you can say, pattern from the data. We needed supervision. But in this case, in unsupervised machine learning techniques, we are having unlabeled data. So data is not having any output values. What we do is we just see the underlying patterns. So we just scan the whole data, look for underlying patterns, and when we find them, we just group them together. Okay. So in this case, we don't we don't provide any guidance. So we have no supervision. That is why it is known as unsupervised machine learning technique. Okay. Now, what are the types of unsupervised learning? So we can also majorly just do this in two. So first is clustering. Second, we can say association. Okay. What is then clustering? What is clustering? Okay, so as we know, unsupervised learning is a technique in which we don't need to supervise the model. It works on its own to discover patterns and information uh, that is present in the data. Okay, so in clustering, what happens? Okay, we find the this pattern in a collection of n uncategorized data. Okay, and here what it does is it processes the data to find natural groups or clusters if they exist in the data or not. Okay, uh, so clustering, now clustering is also having many types. So two which we know is divisive method, agglomerative method. Okay, apart from this, we are having overlapping and probabilistic method. Overlapping and probabilistic. Okay, in divisive, what happens? In divisive method, the data are grouped in such a way that one data only belong to a single cluster only. Okay, in agglomerative, we start with every data as a cluster. Okay, then we iterate it, combining the two nearest cluster with each other, so that the number of clusters are reduced. In divisive, example is k-means. Here agglomerative example is hierarchy. Okay, then what is this overlapping and probabilistic? Let's see. So in this technique, overlapping technique, we use fuzzy sets to cluster data. So here each point may belong to two or more cluster with separate degree of membership. Okay, so the data can be associated with multiple clusters with some membership value. Okay, and here the example is fuzzy C means. Okay, next is probabilistic. In this technique, we use probability distribution to create clusters. Okay. Next is association rules. What is association rules? Now, association rules allow us to establish association between objects or points, we can say, inside a large database. Okay. So this is an unsupervised technique in which we discover interesting relationship between two variables, two or more variables in a very large data set. Okay. So we can say, for example, if people buy a new home, they are most likely to buy new furniture as well. Okay. So this new home is associated with buying of new home is associated with buying of new furniture. We can see. Now next, quickly go towards that. What is reinforcement learning. What is reinforcement learning? Okay, so reinforcement learning is defined as a machine learning method that is concerned with how a learning agent or a software agent acts in an environment or takes actions in an environment. So it is similar to, we can say, teaching a cat how to do. So we know a cat doesn't understand English or other any human language. So we cannot tell it directly what to do. So what we do, we just make a situation where the cat uh, responds in a specific way. So suppose we want the cat to do something, okay, and if it does that thing, we reward it with food. So the next time again, if we tell, that means if we just create that same situation where we want the cat to do something, it will uh, do it more excitedly because it knows that it will be getting reward at the end. Okay, so this kind of learning, we can say it is reinforcement learning. So here we are giving the cat a reward for every time it performs an act. Okay, so it this kind of from this kind of learning, the cat learns to what to do from its positive experiences. At the same time, we can also say the cat learns what not to do also when faced with negative experiences. So suppose the cat brings a dead bird or dead animal to a, it generally does that. So we can just, if the master scolds the cat, so it knows it should not bring that. So it also learns what not to do with negative experiences. Okay. Now, okay. Now, what are the types of reinforcement learning? What are the types of reinforcement learning? So there are basically two types. One is positive reinforcement, and second is negative reinforcement. Okay. So what happens in positive and what happens in negative? So in positive reinforcement learning, okay, we are having the learning agent, okay, and it gets rewarded every time it performs a successful action. So what we want it to perform, when it does successfully, we give them a reward. So we can say it is a positive reinforcement in which we give them a reward. In negative reinforcement, what happens? The learning agent, if it does something wrong or the step we don't want it to do, we penalize it. Okay. So this we can say rewards, we give reward. Here we penalize or penalty, you can say. Okay. So next time the agent tries to avoid this penalty, and in this case it always tries to get the reward. Okay, so next let us see some algorithm questions. Okay, So what is linear regression? So we already know what is regression. Yeah, we already saw here what is regression. So we are having a continuous output here. So what is a linear regression? Okay. So linear regression, linear regression, we can say it is a linear relationship between the dependent and the independent variables. Dependent variables is the output variable and independent variables are the input variables. Okay. So it is a, you can say supervised learning algorithm in which we find linear relationship between these two variables. Okay. Now we have simple linear regression and also multiple linear regression. So if there is only one independent variable, okay, it is known as simple linear regression. And if we are having more than one independent variable, it is known as multiple linear regression. Okay. Now next. So what is logistic regression? What is logistic regression? So logistic regression is a classification algorithm. Okay. Do not get confused. It has regression, but it is still a classification algorithm in which the dependent variable is having binary values. So it only has two values like yes, no, or 1, 0. Okay, true, false. So it is a supervised learning algorithm. Okay, yeah. So it is a supervised learning algorithm uh, in which the dependent variable or the output variable is binary. Okay. Just let's take the last question for today. What is decision tree and random forest? What is decision tree and random forest? So we can say decision tree is a supervised learning algorithm which can be used for both classification and regression. Okay. In this case, we are having a independent variable and a dependent variable. And in this case, the dependent variable can be a continuous as well as discrete. So we are having in a decision tree a root node followed by branch node followed by leaf node. Okay. So whatever nodes comes at the end are the leaf node. Now, how we decide this? We decide this using information gain. Now, what is information gain? Information gain is decided by entropy. Okay. Now, what is entropy? It is the measure of impurity, you can say. Or in simple terms, we can say it is the variance of the data set. Okay. Now, what is random forest? Random forest, we can say, are models, ensembled models, which combines multiple decision tree. Okay, it combines multiple decision tree to create an uncorrelated forest of trees. Okay. Okay, friends. So that was the last question. We can close it now. Okay. Thank you.